Seagulls were dancing all around. I woke up with a sunrise on the sea. Such a precious gift to make. The salty breeze and the waves. The slow pace. The salty breeze and the waves. I'm not around playing. Yesterday we followed the road of the moon. We drove all day towards the coast. It remembered me, the beauty of this life. Such a feeling to be alive. The salty breeze in my lungs.
Morning.
I'm back to where I'm from.
Let's get settled in, and we'll start in about, say 2 minutes. Get your notes ready.
The salty breeze and the waves. The slower pace. The salty breeze and the waves. No matter how place. I want to live
Morning.
in an upper town. Like to see the boats leaving at the break of dawn. I want to live in an arbor town, surrounded by the sea. My art is free. The salty breeze and the waves. The slow pace. The salty breeze and the waves. I'm at the right place.
All right. How are we doing? So, we are going to start chapter 11. This is probably, most likely, unless we have extra time, it's going to be our last chapter. You guys got my email about credit, no credit, right? So, that's going to be that. So, we're just going to get right into it, I guess. We'll talk about housekeeping issues at the end of the class. So then we can talk about what's coming next. Okay. Hello. Alright, so let's start. Today we're going to talk about sector area and arc length of circle. So we're going to calculate them. Okay. Length. Okay. Today's what, 23rd? Right. All right. All right. So first of all, what is a sector area? Sector area is this. All right. As you can see, this sector is from the center and cut by 2 radii and an arc, right? So would you agree that this sector area is basically part of a circle, the whole circle? And the proportion that you cut out, the ratio you cut out, is based on how much angle, how wide this angle is, or in other words, how much this arc measure is. Okay? The whole circle is 360, right? So 360 degrees cutting out n, right? So then normally your area of a circle, right, area is pi r squared, right? But now you're only taking the portion of the circle, right? How much portion? Depends on how much angle you have on your sector. If the angle is large, then you cut out more, and that's out of 360. Okay, so that's the ratio, and you multiply that by, this is called the area of a circle. Am I making sense? Does this make sense? Okay, so you're trying to find part of a circle, you have to do the whole circle times a ratio. Okay, and the ratio depends on how wide the angle is, basically. All right, so let's look at an example problem. So we're going to leave the answers in pi first, and then we'll multiply it out, okay? So, here we go. So, area of a sector, right? So, is, what, pi r squared, right? Pi r squared times 131 is your angle, so 131 over 360. Just like that. Which in this case would be something pi. Because they want us to leave it in pi first and then convert, right? So 131 divided by 360 times 141, 52.4 pi. Or, this is a meter squared, right? Yeah. Or 164.62 meters squared, right? If you multiply the pi out. Okay, so that's number 1. Alright, so try one. A windshield wiper blade is 18 inches long. To the nearest square foot, how much area is covered if the blade angle is 122? So, blade is like this. Right? That's your windshield wiper. Usually you have 2 of them. But here we're just looking at 1. And here we're assuming that the blade is covered all the way 18, okay? Because without it, sometimes we have like a shorter wiping part, and the wiping part is actually smaller than the actual blade, etc., etc. But we're not worrying about that, right? Because they didn't mention how long the actual wiping part is, okay? So we'll just straight do the area then. Pi r squared 122 over 360. What did you guys get? 109.8 pi, or 345. What? 19.15. What? What? Inches. They said round to nearest square inch, right? Huh? What do I want to know? Ooh. Oh. Huh. What? No attendance yet. Okay? We'll deal with attendance in a bit. Don't. Alright. So next part, we're talking about area of a segment, which is this part. Okay? What is a segment? Segment is not a line segment. Okay? A circle segment we're talking about. Okay? So it's right here. So segment in a circle. Okay? Segment in a circle is a region bounded by an arc and its chord. Okay? Arc and chord. So how do I effectively calculate the area? I do the sector, and I cut out this triangle right here. Okay, I subtract out the triangle. So before we continue, I want to remind you that triangle formula, we have two of them. The most basic one was base times height divided by 2, right? So half base times height, that would be the area. Right. The other way that we've done before in trig section is like this. So if we're given SAS situation, then the triangle area is 1/2 AB sine theta. Kind of remember this? Why is it wobbling? You remember that we did something like this before? The area of a triangle. It's going to be useful here, okay? Because most of our triangle here will come from the center of the circle, which will basically be always side angle side. Okay, you'll see. So for example, this one, right? On the left. Find the area of segment, this part, right? Segment, right? Shaded region. So we're going to do sector first. We're going to do triangle. And then we're going to subtract. Okay? Use the segment will be subtraction. Okay? Alright. So, sector area would be what we did before, pi r squared. And times 120 degrees, right? 120 degrees over 360. So that will give me 84.82. Okay? That's the first part. Next one, triangle, which is this part, right? This triangle You have a 9 here, you have a 9 here. Do I know this angle? Yes, I do, because this is 120, then that means this is 120. Okay, so in this case, it would be much easier to do 1/2 AB sine theta over here. Okay, because I know side, angle, side, right? So that's why I mentioned that earlier. So area is half, 9, 9, 9, and then one sine 120 degrees. Okay, multiply out. Oh, just see a parentheses here. So, what do you get? 35.07. Root 3, 4. Root 3 over. 81 root 3 over 4. Somehow that sounds right. No, it's right. You're right. Aditya, you're right. And then you subtract them, okay? Because you just want the segment, right? So it'll be 84.82, that's the sector, minus 35.07, which will end up being about 49.75 centimeters square. Okay? So that would be your answer. Try one. Okay? You guys try one. And once you get an answer, put your answer on the thing, on the chat, so that you can confirm if you get it. So same thing, you gotta find the sector area, which is the whole thing. You're trying to find the segment, okay? That's the goal still. You gotta do triangle, which is this part. And then finally, you can subtract this triangle from the sector to get the segment, okay? That's the idea. You said 55? Nearest 100. Okay, nearest 100. Triangle's 98 is correct. See some good answer here. The pi, Matt, that's called a sector. The pi. Alright, 90 over 360, which is 153.94. Right? Because they want 100, so we gotta make everything to 100. Triangle, right? 14 each side, 90 degrees inside, so it's 1/2 A B sine 90. So this is 196 times 1 divided by 2, so it'll be 98. Okay, then you subtract, right? So 153.94 minus 98, which is 55.94 meters square. Yeah, just type in pi as ETA. If you use 3.14, there's bound to be some different answers, okay? Because you round it too much. Alright, let's test comfort level. Survey, okay? So, from a scale of 1 to 10, 1 being very uncomfortable, 10 being extremely comfortable, how do you feel about page number 1? Type in the chat. Nine across the board. 8, 9, 8, 9. Man. 9, 8, 9, 8, 9. Yeah? You guys, on average, are more confident than the previous 2 classes. Notice I said confident. I didn't say you guys are understanding it better. Because previous 2 classes average is like 7, 8, 6, 7-ish, or 7-ish. This is all 9, 10 across the board. Good. I'm glad you guys are confident. All right, next page. Okay, so the next part is very similar, except that I'm looking for arc length, right? What is arc length? Arc length is this length, actual length, okay, not measure. This length will actually depend on how big the circle is. In other words, how big the radius is. Okay? If the bigger the circle is, obviously this length will be longer. Longer based on the same angle. For example, if this one is 90 degrees in your measure, if this is radius is 1 versus radius is 10, the radius 10 one will be longer. Does that make sense? With the same measure, the bigger the circle is, the longer this actual arc is, the actual length, okay? Now, we talked about how a sector is part of this area of a circle. What is arc length part of? What is arc part of? What is arc part of? Where does that cut from? Where does this arc cut from? Perimeter is a good word. Circumference is what we use for circles, because it's good. But you're correct. That's cut from this circumference, right? So let's think about what circumference is. Circumference, isn't that C equals what? 2 pi r, right? Learned that formula before. So 2 pi r, that is the circumference, right? And then, similarly, you're taking a ratio out of that based on your angle. Same thing as sector area. Make sense? So, I'm not sure what this is, so just ignore that part. Let's look straight at the right side. Okay, the right side. So find each measure. Give answers in terms of pi and round to the nearest hundredth. So let's look at first part. They say area of a sector of Lqm, which is this part, right? So similar to the previous one, we do pi r squared, because this is area, right? You gotta make a distinction what they want, okay? So here they want area, so we pi r squared. R is 6 throughout, right? 6 squared, 75 over 360, which is what? Well, they want it in pi first, then simplify, okay? So we did pi first, and then we simplify. Do we get an answer? .5 pi is correct, which end up being 23.56 meters square. No, inches square. Why do I say meters? Inches square. Okay, inches square. 7.86. Check your calculation. Check your calculation. I think it's 7.86. 36 times 75 over 360, right? So that's the same thing as 75 divided by 10, because 36 and 360 cancel to be 75 over 10. Isn't that 7.5? Then times pi. Okay. Is that okay, Matt? All right, talk about length of NP, which is here. Arc length, okay? First of all, we have to identify these parts first. Obviously, these are 6. What is this angle right here? What is this? What's this measure? .75. It's called vertical angles are congruent. Okay, so vertical angles are congruent. So lengths of NP would be based on that, but this is length, right? So it's based on circumference. So 2 pi r times, r is what? 2 pi r, r is 6, right? 6. R is 6. 2 pi r times same ratio, right? 75 over 360, which would give you how many pi's? 2.5 pi, I think. And then this ended up being 7.85 inches. Notice that the unit is in inch, not in inch square, because inch is your length unit, right? We're talking about length. Okay. Good. So why don't you take some time to look at the challenge problem? Okay? And once you get an answer, you can type it on the chat. But before we do that, let's take attendance. If you're here, just type here for formality. Since you're here anyway, so you just count. Okay, I want to make sure that I don't miss anybody. So please type here if you're here. All right. Anybody see Anjali? Oh, hi Anjali. Looks like that's pretty much it, right? It's everybody. Oh yeah, hi Prarit. Okay. Any good ideas on doing this one? There are many ways to do this one, okay? Many ways. Oh, wait. I didn't give you length. Haha, this is both 3 inches, okay? 3 inches and 3 inches. Nobody even asked for that. You need a length unit for this, okay? Otherwise, if you don't have the length, there's no way you can solve this, okay? So both of the width are 3. Okay? I'll give you some time on this one. Want some Kahoot music? Serby, you're close. You're within 50% correct. Meaning like a pair you're closer. I think you're like you're within 2 pi correct. Within 2 pi correct. 70.69 is correct, Darren. It's correct. Is the shape twice the size of the inner area? No, it is not. 70.7 inches square. I think you're correct, Sneha. 22.5 pi is correct, Archita. Shall we take a look? So, there are many strategies to do this. You can do 2 sectors. Okay, you can do the large sector, which is a radius of 6. Okay, so there's 2 ways to do this. One way, you can do large sector, which is radius of 6, subtract small sector, which is radius of 3. You guys understand my picture? Okay, if you do it like this, then it would be the angle here is gonna be what? 300 divided subtract 60 will be 300, right? Both of them are the same. So you can literally pi r square 300 over 360 subtract pi 3 square 300 over 360 because they're the same angle, right? You don't have to simplify. You can leave it like it. If it didn't say, you can leave it as it is. Okay. So that's one way to do it, right? Or number 2, you could also find a donut first and then multiply by 300 over 360. Okay, either way you'll get the same answer. Well, how do I get the donut? Donut is what? Pi r squared minus pi r squared. Right? So big circle is pi 6 square minus pi 3 square. And then you multiply by 300 over 360. If you compare the 2 different methods, you realize that they're the same thing, right? Except one you factor out 300 over 360 and then subtract first. The other one you do it separately and multiply them separately. Does that make sense? John's problem. All right, so that is area and sector, area, arc length. Okay. The last thing we want to look at is a different system / unit to measure an angle. So far the angles we use, we always use degree, right? There's no other units to measure the width of an angle, or like to measure an angle basically. Okay, so today we're going to introduce another unit called radians. This is almost like, a different unit, like, you use feet and inches, you use centimeters and inches, like you have different system of calculating the same thing, right? For example, how many inches is in 1 feet? 12 inches, right? For example, something you don't know, 1 inch is actually around 2.454 centimeters, right? These are called unit conversions, right? So in angles, we have something similar called degrees and radian. Now, before we continue, we have to think about how radian is defined and how it works. So you see in radian, good point, we're going to get to that, Prayer. We're going to get to that, okay? So first of all, to figure out what Prayer is wondering, how many degrees are in a radian, let's look at how radian is defined first. So this is 1 radian. 1 radian is such that if I'm in a circle, my radius is exactly the same length as my arc length. You notice that I say radius on both. So when they are at the same length, this angle right here is called 1 radian. So before we try to figure out how many degrees, let's figure out how many radian should be able to fill out the whole circle. How many of them? Okay, that's the first question. All right, think about that. How many radians can I fill out the whole circle? Okay, whole circle. My hint is it kind of has to do with this one. Okay, kind of has to do with this one. Some people say 5, some people say 6, some people say 8. So radians is kind of relative to radius, right? So how many radius can you fit in this circle? Can you be more exact? How many radius are in one circle? Well, the whole circle is filled with what? Circumference, right? What is the formula for circumference right now? 2 pi r, right? Did I tell you how many r's there are? 2 pi, right? So it's around 6.28. Okay, 2 pi of those. So around 6.28, which is 2 pi, basically. Okay? Now, no. Hey, that means how many radians are in the whole circle? 2 pi, right? So 2 pi radians is equal to how many degrees are in the whole circle? How many degrees? With the same angle, how many degrees? How many degrees? Isn't that 360 degrees? So now can you get the conversion? 2 pi radians is 360 degrees. Okay? So 1 radian is equal to, right, exactly. So if you can convert, pi radian would be 180, right? Degrees. And you can divide pi over, so 1 radian is actually 180 over pi degrees. And then on the opposite hand, 1 degree is pi over 180 radian. Okay, so this is your conversion if you're looking for one. So 1 radian is 180 over pi is about 57.3 degrees. Okay, about. Okay? Kind of makes sense? So let's try to use that to convert. Okay, let's try to use that to convert. So the first one, 30 degrees. 30 degrees, I want to make it radian, right? Pi over 180, right? 1 degree is pi over 180 radian, which is pi over 6 radian. Make sense? Because you cancel, right? 6. 1.5 radians, similar, but on the reverse, right? So 1.5, you have to do radians. 1 radian is that much, so 1.5 times that much, which is, I think, going to be around 85.94 degrees. Okay? So that's the conversion between radian, degrees, vice versa. Okay? You can. Yeah. Yeah. But you need 2 pi, right? Because 6.28 is 2 pi. Yeah. So, comfort level on this section. We're going from 1 to 10 again. Can you give me a number so I can comfortably move on? I know you guys are confident, but radians and degrees is sometimes difficult to grasp. So what do you have? 8 is good. Anything else? You can be honest, okay? You don't have to, like, you know. Okay. 8 and 7 is decently good enough. So, housekeeping items, I got these. So, there are several things coming up. Obviously, we're doing credit, no credit, so there are several things I have to say. Bottom line is this, okay? If you feel that you've been keeping up with the work and you've been doing homework, etc., 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 you should get credit, okay? The only reason why you shouldn't get credit in this class is that you start slacking off now and you start not doing anything. Doesn't matter what grade you had before, okay? Make sure that you keep up the work, do the homework, come to class, etc., etc., okay? It's all in the email that I sent. So that's the first thing. Now, then, the homework for this week, there are 2 sections. Together, there's around 20 problems, okay? Because a sector area and arc length are in different sections. So I made sure that I picked some from each. And they are due Sunday at night, okay? This Sunday. Now, chapter 10 test is going to be open book, open notes. It's going to be in 2 weeks, the 8th of Friday. It's around 20 problems. You can do it for the whole day from 7:20 a.m. to 11:59 p.m. This is a individual test, so please don't discuss with anybody. I can trust you guys, right? You guys are trustworthy. Staring at your eyes virtually. Trustworthy people? Anyway, so let's assume that you're trustworthy. If we assume that and we don't get any contradiction, then that proves that you guys are trustworthy, right? All of these will be on big ideas, okay? This test is going to be available starting 7:20 a.m. in the morning. You log on to Big Ideas. You will see this under your assignment, okay? Okay, Joseph, okay. No, Parrot, that's the whole point. We have to do it not sooner, so that way we we can review and we can kind of ease into it and give time to study as well. Okay? Okay? You need to give people time to study. Although it's open notes, open book, it's still like Also, for those of you who haven't been doing your big ideas homework, give you a warning, okay? You gotta do your big ideas homework. I noticed that homework complete percentage has decreased ever since we got virtual, which is not good. Very not good. Okay? So, okay. Make sure you do your homework. Okay. Any other questions before we continue? Joseph, in the end, after you finish everything, there should be a submit button. If you don't have a submit button, I'll submit for you, okay? Regardless, okay? I can click submit, but make sure you save all your problems, okay? Make sure you save all your problems. Yeah. Do I eat beans? Sometimes, I guess. All right. Any other questions before I let you go? By the way, I shaved my head. Not like you guys can see it, but... All right. All right. Until next time. If you have any questions, hit me on Remind, hit me on email. Books return is not gonna happen until probably school reopen, which is like next year, I guess. So that's something that we're not worrying about at the moment. Okay. Your hair is now longer than your forearm. I don't remember your forearm being very short. All right. So until next time then. The final is gonna be similar to chapter test. It's probably gonna be a little longer than a day, but I'll do something similar. Okay? Does that make sense? If I figure something out other than that, then I'll update you. Okay? It's not gonna be as high stake, obviously, but that's how it's gonna work. Okay? Goodbye.